Good afternoon, everyone. Welcome to Quantum Chemistry. So, Maxwell theory on electromagnetic waves started the quantum chemistry field, which he theorized that electromagnetic wave has an electric field component and a magnetic field component. No, these two components have the same wavelength and frequency, hence the same speed, but travel in mutually perpendicular planes, such as this one. Okay, so you have your magnetic field, um, which is perpendicular to your electric field. This is actually your electromagnetic wave, which is more familiar to you as seen in this spectrum. No, you have your radio frequency, microwave frequency, um, infrared, visible, ultraviolet, X-rays, and your gamma. Ang pinaka-renowned here is actually the more observable region, your 400 to 750 nanometers, your visible region. Okay, so it was James Clerk Maxwell who proposed that visible light consists of electromagnetic waves, which is composed of your electric field component and your magnetic field component perpendicular to each other. Okay. Usually you need to memorize the specific region for your visible region. It is between 400 to 750 nanometers. Typically, mag 800 pa pa. Okay, so 400 to 750 nanometers is your visible range. Okay, so lowest, this is the length of your wavelength. Now, as you go here, the wavelength increases, and as you proceed from here, your frequency increases. Remember that frequency and wavelength are inversely proportional. No, so as you increase your wavelength, you decrease the frequency. Okay, so the longest wavelength here would be your radio waves, and the highest frequency spectrum would be your gamma rays. So it was actually Neil Bohr, as discussed last week, who hypothesized that an electron in a hydrogen atom moves around the nucleus in an allowable circular orbit. So his perception of the atomic model is actually in 2D. Kaya ginamit ang word na orbit. Okay? So he hypothesized that electrons could only move around circular and allowable orbits around your nucleus, which is actually not the case not today, because you know that your atom is 3D, no? So actually electrons are free to move around. Okay, um so the line spectra of your hydrogen is actually represented in here, you know. Each wave number accounts for a light emitted when a atom when when an electron moves from a higher energy level to a lower energy level. Okay, this transition this transition releases energy in the form of light. Kaya for example here, you have your 656 nanometer corresponding to your red light, green light for the 486 nanometers, and 434 nanometers for your blue light. Okay, so it was enough to explain the line spectra for a hydrogen-like atom. No? So Bohr model is actually correct for on one electron species, okay? But hindi na siya nag-reflect to other atoms that has more than one electron. Hence, it was then the Bohr model was then replaced with your quantum atomic model in 1920s. Okay, why? Because the Bohr model didn't take into account the some quantum physics principles that was discovered later on. For example, that particle could also behave as a wave. Okay, so more on that. Okay. So, ang perception ni Bohr is that your electrons move around your in an orbit, no, allowable orbit in your atom, okay, in your around your nucleus, okay. So, which is not correct, especially for multiple species atoms, multiple electron atoms. So, more on the electronic structure of the atom. Later on, we will discover that particles could actually behave as wave, no? So, meron din silang wavelength, amplitude, frequency, and speed. Okay, wavelength is your typical distance between two adjacent peaks or two adjacent troughs, okay, or troughs. Okay, this is your wavelength. This is your wavelength. Then amplitude naman is a distance between the origin and your crease, no, or here to here or here to here. Okay. Frequency naman is the number of complete wavelengths or cycle that passes a given point each second. So how many complete wavelengths or cycle passes through a single point each second is actually their frequency. Okay? Alright, so speed naman is a wavelength times frequency. So if you multiply wavelength and frequency, you will get the speed, okay, of your wave. Right? So you remember your wavelength, amplitude, frequency, and speed. So more on that, as you can see, there is a inverse relationship between frequency and wavelength of the electromagnetic radiation expressed by the equation. Okay, lambda is your wavelength, v or your Greek letter nu is frequency, which is usually measured as s minus 1, no, or hertz. Kaya nga siya, 'di ba, number of complete cycle per second kasi ang unit na ginagamit dito is hertz. Okay? Your speed of light is your 3.0 times 10 raised to 8 meters per second. Okay? That is your speed of light. Okay? So, as you can see here, as inverse ang relationship ni frequency and wavelength. Okay? As you increase your wavelength, you decrease your frequency. As you increase your frequency, ga-decrease ang imong wavelength. Okay? So more on that. So this is a typical problem that you can encounter in inorganic chemistry or in physical chemistry na mga type of questions. So for example, in sample 6.2, the yellow light given off by the sodium vapor lamp used for public lighting has a wavelength of 589 nanometers. What is the frequency of this radiation? So you would just use your equation from here, no? Ito, si lambda times nu equals the speed of light. So, you can pause this video and try to answer sample 6.2. Okay? So, if you are done, this is actually the answer for that. Okay? Solving for this is actually using this equation and just rewriting it in terms of your frequency kasi frequency ang hinahanap, 'di ba? So, you have your speed of light over wavelength, okay? Since the units are in meters and nanometers, you convert one over the other, no? So since y- we want to cancel out the meters because ang ginakuha or the one being asked is actually frequency, then your unit in I'm sorry, should be in hertz, no? So S minus 1. So you should know the basic conversion unit of meters into nanometers. Okay, so there's actually in 1 nanometer that is actually equivalent to 10 raised to negative 9 meters. So if you cancel out this one and this one, so it also cancels your nanometers. Then you're left with your unit, no? So frequency, which is your S minus 1 or hertz. So the frequency of the sodium vapor lamp used for public lighting, which has a wavelength of 589 nanometers, is actually 5.09 times 10 raised to 14 S minus 1. Okay? So this is your a typical example of calculating for the frequency when the wavelength and speed of light is given. Okay, so typically speed of light is not given, so you need to memorize the value of your speed of light. Usually, ang value for speed of light and other constant is already in your calculator. You just need to know how to tweak your calculators to give you a constant value. Okay, so more in that, it was actually Rydberg, no? Rydberg equation is actually often used to allow us to calculate the wavelength of all spectral lines of a hydrogen. Okay? Um, Rydberg equation is may limitation lang siya. It's primarily used only and is only applicable to hydrogen-like atoms. So, hydrogen-like atoms sa mga one electron species lang. Okay? For example, is your helium plus, no? because it only rely on the assumption that a single electron is experiencing the full nuclear charge of your um, nucleus, no, or proton and neutron without any significant electron-electron interaction from any other electron species. So you only use your Rydberg equation for hydrogen-like atoms, such as your helium plus. Okay, so atoms can absorb or emit one photon when an electron makes a transition from one stationary state or energy level to another. Okay, absorption or emission depend if you transition from a higher to lower or lower to a higher orbital. Okay, when atoms are exposed to flame or high energy, these electrons are excited to a higher energy level, and when they fall back, they release energy in the form of light. Okay, that is your line spectra for your hydrogen. Okay, so every line spectra um, is equivalent to an electron being excited, then being emission of your electrons. No, so every emission of your electron correspond uh, to a light. No, so that's the emission of your electron. But take note that not all transition are experience or are able to produce light. Kaya ang mga part na to is black because not all transitions will produce light. Okay? So there are only few lines spectra here because those transition are actually in the part of your visible range, no? So not all transitions will produce light. Okay, so memorize your Rydberg equation, no? So your Rydberg equation is actually derived from from this one here. So you can search for the derivation of your Rydberg equation, but in most cases during examination you don't have the time to derive equations, no? So mostly gonna memorize na lang. So you can memorize this part here and this one. Okay, so okay. So you have your 1 over lambda or your wavelength equals your Rydberg constant, which is 1.09667 times 10 raised to 7 meter negative 1, no? So 1 over meter, and 1 over um your final NF, which is your final or lower level, kaya diba ga-emit ka, so bali pupunta ka sa lower orbital or lower level. Okay, and your I naman is the initial or higher level. Okay, so if you emitted from say 3 to 2, then your final lower orbital or energy level would be 2, and your Ni naman is your higher energy level, it would be 3. Okay, so don't mix the two kasi mag-iiba ang sagot mo. Just remember that NF is always greater than Ni. Okay? NF dito. NF is always less than Ni. Okay? So emission are from a higher to lower, where your lower energy level is your final energy level. Okay? Also remember that not all transition will produce visible light. Hence the dark spaces here. Okay? Only certain transition are are visible. Okay, so more in that you could write so Rydberg equation is used to find the wavelength as well as the energy of the photon, no, kasi energy of the photon is actually equivalent to your Planck's constant over your wave lambda, or lambda times your speed of light, no. So if you actually um equate these two equation, then you could actually get the energy of a photon in corresponding to the emission, no? So minsan pinapahanap ang energy of the photon. Okay, so you just need to correlate this equation to this Rydberg equation, then you can actually find the energy of your photon. Okay, so first you find the wavelength, which is given sa imo, which you can solve coming from your Rydberg equation, and then you can plug it here plug it here since your Planck's constant is actually constant, no, So and your speed of light is constant. So if you have your wave length calculated, then you could actually calculate